Now let's go over this problem. Given that a log of x to a base of 2 is equals to m, and a log of y to a base of 2 is equals to n, express in terms of m and n. Option A, the log of 8 multiplied by x to the power of 3 multiplied by y all to the base of 2. So let's begin by dealing with this problem one after the other before we proceed to the next. So for the first option, we are to express in terms of m and n the log of x cubed multiplied by 8 multiplied by y all to a base of 2. Now the first thing we want to do at this point is to actually simplify this log to the lowest term. And to do that, we can actually apply the product identity of logarithms, which says that this in simplest form will be log of 8 to a base of 2 plus log of x to the power of 3 to a base of 2 plus log of y to a base of 2. Now at this point, we can actually focus on the log of 8 to a base of 2, since 8 is the multiple of 2. In how many different ways can we multiply 2 with itself that will result in 8? It turns out that 2 multiplied by 2 is indeed equals to 4. However, 4 multiplied by 2 will result in 8. So in index form, 2 to the power of 3 will be equals to 8. So the next we want to do is just to replace 8 with 2 to the power of 3, so as to make it easier for us to simplify. So I'm going to get rid of this. Now the next we want to do is to replace 8 with 2 to the power of 3. I'm going to have this plus log of x to the power of 3 to a base of 2 plus log of y to a base of 2. Now at this point, to make it straightforward, we can just apply the power rule of logarithms to any of the identity or any of the logarithms values. We observe that the rule can be applied to. Now it turns out that we can apply the rule to this and this, because they all have an index, and the power rule says that the index can come to the front of the logarithms. So therefore, this expression returns to 3 multiplied by log of 2 to a base of 2 plus 3 multiplied by log of x to a base of 2 plus log of y to a base of 2. Now I've actually run out of space, so I will actually need to get rid of some stuffs. Let me just get rid of the first one instead. So this is gone. Now at this point, log of 2 to the base of 2 is indeed equals to 1. So therefore, we're going to be left over with 3 plus 3 multiplied by log of x to a base of 2 plus log of y to a base of 2. Now that we have gotten to this point, it's easier for us to substitute the given values. If you could recall, back to the question, we have to leave our answer in terms of m and n. So at this point, it's easier for us to substitute. We have to assume, or we have to replace log of x to a base of 2 with m, and log of y to a base of 2 with n. So therefore, our final answer in this case is 3 plus 3 multiplied by m plus the value of log of y to a base of 2, which is simply equals to n. So our final answer for the first question is 3 plus 3m plus n. Just keep that in mind as you might be needing it as we move forward. Now let's talk about the next question, part B. Part B says that we should also express in terms of m and n the log of y over 2x to the base of 2. Feel free to pause the video and try to check this question. So we have log of y all divided by 2x to the base of 2. Now just like before, all we need to do is to first of all simplify this to the lowest term, and to do that we will need to apply some of the identity of logarithms. Now it turns out that we are having two different values to be dividing themselves in this case, and not multiplying themselves. So therefore we are to apply the quotient law of logarithms, which will turn the expression to become log of y to the base of 2 minus log of 2x to the base of 2. Now it turns out that the log of 2x to the base of 2 can also be split into a simpler form. And to do that, you can just apply the product law of logarithms. And doing that, we're going to be left over with log of y to the base of 2 minus log of 2 to the base of 2. Then it will actually be in a parenthesis because we will need to expand the parenthesis. Log of x to the base of 2. Let me make that a little bit larger. Good. Now the next thing I want to do in this case is just to expand the bracket with the negative sign. So I'm going to have minus log of 2 to the base of 2, then minus log of x to the base of 2. Now at this instance, it's easier for me to turn the log of 2 to the base of 2 to become y, and substitute the values. That's that was actually a mistake. Okay, I just want to make sure that it is perfect. Good. So the log of 2 to the base of 2 is normally means that it's actually equals to 1. So I'm going to be left over with log of y to the base of 2, the minus 1, the minus log of x to the base of 2. Now at this point, it's easier for us to substitute the given values. We are to replace log of y to the base of 2 with n, and log of x to the base of 2 with m. So final answer in this case is n minus 1 minus m, and that's it. And that is the final answer to the second question. Now what about the last one, which is the part C? We are to they said given that log of 8x cubed y to the base of 2 is equal to 20, and log of y over 2x to the base of 2 is equals to 0. Find the value of m, n, x, and y respectively. So let's begin. We are to solve for m, n, x, and y. So for me, I'm gonna start by solving for m and n first. Now, if you could recall, I said you should write the solution we have for the first option we did, for the part A. I said you should write it somewhere. If you jot it down, perfect. What do we have as our final answer? We turns out to have 3 plus 3m plus what? Plus n. And we said it is equals to the solution to log of a base of 2 of 8x cubed, then multiply by y. At the same time, for the second problem we solved, which is the part B, we said we have n minus 1 minus m as our final solution, and we said it is equals to the simplification of log of y all over 2x to the base of 2 in terms of m and n. Now, the question has made it easier for us. They said we should let log of 8x cubed multiplied by y to be equals to 20, and log of y over 2x to the base of 2 to be equals to 0. So definitely, if that should be the case, it should be easier for us to solve for m and n simultaneously. So this is equals to 20 and this is equals to 0. So to make it short, let me actually fish this out. So therefore, 3 plus 3m plus n will be equals to 20, and n minus 1 minus m will be equals to 0. Now, the next thing I would like to do in this case, let me actually try to break this into pieces for you to figure it out. I will like to subtract 3 from both sides, okay, in order to have variables at one side and constant term at the other side. So I'm gonna be left over with 3m plus n to be equals 20 minus 3 is indeed 17. So I will assume this is equation 1. Now for the second part, which is n minus 1 minus m, I would like to add 1 to both sides so as to what? Keep everything intact. So n minus m will be indeed equals to 1, because 0 plus 1 is positive 1. Now at this point, I'm just gonna solve for m. So let's say this is equation 2. Okay, I would like to solve for m in equation 2, or let me set n to keep it simple. So let me just create some space. By the way, this is actually a simultaneous equation. If you are familiar with any other method, feel free to use any method you think you are good with. So what I'm trying to do is that I'm just trying to use the substitution method. So I want to make n the subject of formula in equation 2, and to do that I can actually add m to both sides, and left over I will have my n to be equals to 1 plus m. So the next thing I will do is to put put 1 plus m as n in equation 1. Hopefully you can see that. So therefore, equation 1 is 3m plus n is equals to 17. If I want to replace n with 1 plus m, so therefore I'm going to have 3m plus, in a bracket, 1 plus m, then close the bracket to be equals to 17. Now at this point, I can just expand the bracket with the positive sign by just distributing it to each and every value in the parentheses. So therefore, 3m plus 1 plus m will be indeed equals to 17. The next thing I would like to do is to subtract 1 from both sides and add m and n together, then take 1 to the side. I'm going to add my final result to be 4m to be equals to 16. So therefore, the final value for m will be 4, because once I divide both sides with 4, I'm going to have m to be equals to 4. So m is equals to 4. So the value of m in this case is 4. Now, here is an equation we formed here. Normally we're supposed to name this equation equation 3. So let's assume it is the third equation. So the next thing we'd like to do is to say that put 4 as m in equation 3, and then boom, you get the value of n. Since we said equation 3 is 1 plus m, so therefore n will be equals to 1 plus 4, which is indeed 5. Now that we have the value of m, likewise the value of n, to be easier for us to solve for both y and x. And how can we actually do that? Just stay tuned. Go. Now, to solve for x and y, we will have to use these equations over here. We are told that n is equals to log of y to the base of 2. Also, m is equals to log of x to the base of 2. So definitely we can use the definition of logarithms to solve for x and y, since m and n is known. So we have log of y to the base of 2 equals to n. When m is 4, log of x to the base of 2 will be equal to 4, and log of y to the base of 2 will be equals to 5. Applying the definition of logarithms, it is what? The 2 will raise this value. It is an index to which a base is raised. That is basically the definition of logarithms. So x will be equals to 2 to the power of 4, and y will be equals to 2 to the power of 5. 2 to the power of 4 means 2 multiplied by itself in 4 places. That's actually 16. And 2 to the power of 5, that is 2 in 5 places, is actually 32. And we have our final results. Hopefully you now enjoy and knows how to handle some typically word problems involving logarithms. Now, here's some exercise I have for you. Here's the first one, and here's the second one. So try to play around with these questions. Feel free to share your answer with me in the comment section below, and I will make a review on it and reply to it as soon as possible. Thanks for watching. See you guys in the next video. By the way, if you haven't subscribed, do well to subscribe, and don't forget to give this video a thumbs up, because that is exactly what will tell YouTube that the video is like. See you in the next video.